This lesson will cover the solubility curve practice problem worksheet. So what we're going to do is we're going to use the graph below here to answer the questions. And if the question does require a calculation, make sure you show all work to receive credit. No work, no credit. And remember your units. So let's first off take a look at this graph. The title of the graph is called Solubility as a Function of Temperature. So when you look at this graph, you can see that there are various labels. There's calcium chloride, potassium chloride, sodium chloride, potassium chlorate, and so forth. On the y-axis, we have the solubility, and that's how many grams of that particular solute will dissolve in 100 grams of water. And on the x-axis, we are provided the temperature scale goes from 0 degrees Celsius up to 100 degrees Celsius. So let's just kind of get a feel for the graph first. So you can notice then that most of these lines are increasing as you increase the temperature. So that means that there's going to be more solubility as you increase the temperature. There is one exception to that, and that's Ce2SO4. As you increase the temperature, you can see that the solubility, which is on the y-axis, decreases. So what do these lines represent? First off, these lines represent the maximum amount of material that will dissolve at that particular temperature. So for example, at 10 degrees Celsius, the maximum amount of calcium chloride that will dissolve, you go up, you hit the line here, and then you go over to the left, and you can estimate that it's going to be approximately 63 grams will dissolve in 100 grams of water. So this is called the saturation point. That's where you have the maximum amount of material that will dissolve in 100 grams of water. And that changes with temperature. If you're below the line, so let's say the temperature is 10 degrees, but you put in 50 grams, you notice then for CaCl2, that is below the saturation line. So we call that being unsaturated. So in other words, you could put more calcium chloride into the solution and dissolve it. If you're above the line, there's two things that could possibly be happening here. You can have something that's called supersaturated if the material still dissolves, but that's a very rare occurrence. Typically what happens if you're over the line, what's going to happen is you added too much calcium chloride in the water at 10 degrees, and basically the difference here would be basically at the bottom of your container, and it will not dissolve no matter how much you stir the solution. And you may have had this happen again, going back to the Kool-Aid example, where you add too much Kool-Aid powder in, and no matter how much you stir it, it's not going to dissolve. It just settles down at the bottom. You could have supersaturation, but again, that's a very unusual, very unique phenomenon. On your worksheet then, let's answer a couple of the questions. Number 1A, it asks, what is the solubility of calcium chloride at 5 degrees Celsius? So first off, you want to come over here to the x-axis and estimate where you have 5 degrees Celsius. And then you want to find the saturation line for calcium chloride. So if you go up the table here, this is the saturation line for calcium chloride. So this is where it's going to be saturated, and if you go then to the left, this tells you how much will dissolve in 100 grams of water. So you'd have to estimate it somewhere around 62, 63 grams of water. Moving on and looking at question number 2B, it asks, what is the solubility of cerium sulfate at 50 degrees Celsius? So again, you locate the 50 degrees Celsius on the x-axis, and you go up to the saturation. So this again is where the material, the maximum amount that will dissolve in 100 grams of water, and then go to the left and find out, and again you'll have to estimate to the best of your ability, what is the solubility. So again, it's an estimate 3 or 4 grams of cesium sulfate for every 100 grams of water. So what's happening here with Ce2SO4, you can see then what's happening to the saturation line here. As the temperature increases, the solubility decreases, and then it pretty much remains the same after 40 degrees. On the back page, we have a couple calculations to do. So number 3 asks, what is the mass of cerium sulfate that will dissolve in 50 grams of water at 10 degrees Celsius? So first off, you go back to your graph, you locate 10 degrees Celsius, and you estimate that at 10 degrees Celsius, it's going to be about 10 grams per every 100 grams of water. But in the problem, you are not given 100 grams of water. You're only given 50 grams. So you just simply set up a proportion. If you have 50 grams of water, how much will dissolve? Simply then cross multiply, use our math skills, cross multiply 50 times 10 divided by 100, and you get about 5 grams dissolved at 50 grams of water. So again, the amount of water changes the answer. The 10 grams at 10 degrees may be a little high, but again, if you use 11 grams, that's fine. It's all approximate from the graph. For number 6, it asks you to have a saturated solution of potassium chlorate. So of course we know potassium chlorate's formula. It's dissolved in 100 grams of water. If the saturated solution is cooled from 90 degrees to 60 degrees, how many grams of precipitant will be formed? So again, you go back to your graph on the front page, locate 90 degrees, and find the line, the saturation line, and go over to the left, and it's about 40 grams will dissolve for 100 grams of water at that temperature. What happens then at 60 degrees? Well, at 60 degrees, because it's colder water, you're only going to dissolve 22 grams in 100 grams of water. So again, you get that off of the graph. So what's the difference then? So if you take 40 minus 22, that means that when you lower the temperature, you cool the solution, 18 grams will not dissolve. So basically it settles down back at the bottom of the container. And again, no matter how much you stir the solution, it will not dissolve. Complete the rest of the questions then based on the video, and you should be successful with that.